Welcome. Thank you for coming by. This is Lucas, and I'm Connor, and we're here from the base team, the Smart Wallet specifically, and we're here to talk about this new feature we're launching soon called Spend Permissions. So Spend Permissions, that title got messed up, sorry. Spend Permissions allow you to create one-click or no-click experiences that can spend users' tokens. This is important because we all want better UX within Web3. It's kind of annoying to have pop-ups all the time when you're doing a transaction. And so with Spend Permissions, you're able to give permission to an app to spend your tokens so that the app can do fancy transactions to pull your assets and then do fun things with them. And this workshop is going to show you one of those things is a social app. And so today we're going to talk about how it works for a brief few minutes, talk about our roadmap when we're launching this and when you can get started building. And then we're going to talk about some fundamentals. This is where the workshop actually begins. We'll be doing some live coding, and you can fork our starter repo. And then we're also going to be finishing with an NFT micropayment use case at the very end. So for those of you not familiar with Smart Wallet, it is a smart contract account that has self-custodial passkeys. This means that users can easily onboard if they have a device that supports passkeys, which is most people in this room. You can scan with Face ID if you have iOS, or thumbprints if you have your computer or your phone with a thumbprint scanner. With Smart Wallet, you can also sponsor gas for transactions so users can convert easier and not have to fill up their wallet to get started. And you can also batch transactions to make it easier for people to do things with less steps. But one of the problems we've encountered with Smart Wallet and all wallets in general is that there's still too much friction to transact. People really are addicted to one-click experiences like we have in Web2. So there are two ways that we've actually explored doing these one-click experiences, and Session Keys is where we actually started. And it's this idea that you can give permissions to apps to transact as you. And so literally the popular way people implement this is they can take control over your account to call other contracts. And it's incredibly flexible, but after exploring this deeper, we realized that this actually has some security discomfort for us, and we don't want to let apps call random contracts on our behalf, even if we inform the user what's being called and what functions. We just don't believe that users are informed enough to give approval to those kinds of permissions. And so that's what brought us to Spend Permissions. It's a way of tightening the scope of what we allow apps to do on behalf of our accounts, and it's focused only on spending assets. We think that spending assets is actually the majority of the reasons apps need to interact with accounts. And after an app has assets from the user, it can then do things like mint NFTs, swap tokens, staking on DeFi, whatever you need. And in this sense, we actually feel way more confident with the security posture of spend-only permissions, and you can still solve the majority of the things we care about. So what are the use cases we think people want to build with? The first, which we'll demo today, is microtransactions. These are high-frequency interactions that you'll want users on your app. Because they're high-frequency, it's naturally very annoying if you have a pop-up every single time. And so use cases like this in social would be a Zora app, where it's basically Instagram, but instead of liking, you're collecting NFTs, you may be liking all the time. Other microtransaction examples would be gaming, very high frequency. People want to go through many operations for a game potentially and do it quickly. And so before, you would have a pop-up every time, but now you can just give permission once to spend some ETH or an ERC20, and then whenever you click a button or do something in the background, it's just going and transacting without you noticing. The second use case we're really excited about is subscriptions. This is an example of a pattern where users don't have to be on the app anymore. And this is where permissions really shine, and you can do things uniquely that we couldn't do before with wallets. And so in a subscription case, you will give your app permission to spend your tokens on some recurring basis. And then even when you're outside the app, it'll just pull money from your wallet, no pressure needed. And so in this case, subscriptions are not the only background process you need to do. Other background operations could be automated trading, copy trading. Things that are more DeFi native also shine very nicely with background transactions. But these are the two that we think are most relevant immediately. So how does this actually work? So this is a sample diagram of what on-chain looks like. And typically a smart wallet, we think of having one or a few passkey owners. And so you can see the smart wallet contract in the bottom left. It has an owner relationship to a passkey. And we typically reference that passkey by its public key, so 64 bytes. Smart Wallet also supports owners that can be Ethereum addresses, which includes smart contracts. And so for the spend permission system, we're actually adding a new contract as an owner to smart wallets called the permission manager. And through this ownership system, we're able to delegate other permissions to spenders. And so you can see the spender relationship between our permission manager and a spender entity, which is itself another Ethereum address. And so once you have this ownership relationship set up, the flow of a transaction looks a bit different than normal. So originally, transactions for session keys originate from the smart wallet account, but this time a spender is calling through the permission manager to spend some tokens, and then the permission manager, being an owner, is able to call execute on the smart wallet to get it to call anything at once. In this case, we want to call the smart wallet to transfer some value, and in this case, back to the spender. And so, yeah. And so how do you actually use this off-chain? The first thing we need to do is approve a permission from the user. We do this with ETH signed type data. It's using EIP 712 signatures. We chose this path because it's the easiest way to ask the user for a signature of structured data. Before, we were working on a standard called ERC 7715. We felt that 712 was actually an easier place to start, but we're still open to working with 7715 in the future. But the user sees a very simple approval here, where the app is just asking them to allow it to spend some currency on a recurring basis. In this case, 10 USDC every month could be a very simple transaction subscription experience. And we also have a start and end time. So in most cases, you'll want the start time to be right now and the expiry to be sometime in the future. The apps we've been talking to typically want the expiry to actually be infinite, which is something we think is interesting, where users would have to revoke if they ever want to remove the permission. But that's up to every app to decide for themselves. After the users approved a permission and then therefore signed it with their passkey, the signature is given back to the app. And now the app can use that signature to apply it as an approval on-chain. And that's that first optional call in the top. After a spender has approved the permission with the signature from the user, it's able to spend. And so then that's number 2 on this diagram, where the spender is calling into the permission manager to use the permission. The permission manager will then validate it, call execute on the smart wallet, and depending on if you're using native token or ERC20 token, the smart wallet will either call directly back to the spender to transfer ETH, or call the ERC20 contract with the transfer function to send the tokens. The third piece here is revoking. It's very important that users are always able to revoke permissions after they've approved them. This is fortunately a way we can actually differentiate from TradFi and the existing world, because it's very frustrating that you can subscribe to an app but not easily unsubscribe. A lot of apps make it very difficult, but we believe that in the new world, users should always have control over their assets and have control over their permissions. So permission management is always easily accessible within their smart wallet settings. And we also went through the effort of making revoking an entire app's permissions, in case you have multiple, easier with a batch revoke as well. So when can people start building with this? Well, as of today, we have, well, as of last week, we have Base Apolia supporting ETH and ERC20s. And in December, preferably at the start of the month, we're going to have this live on mainnet. On all mainnets that Smart Wallet supports. Right now, that includes Base, Arbitrum, OP, Zora, ETH mainnet, and a handful of other chains that are less used right now. But also in December, we're exploring ways of doing batch permission approval. So ways for a subscription, for example, that you can both pay now, but also give permission for the app to take your money later, which is a more typical experience that we have with permissions for subscriptions. And then in 2025, the roadmap is still pretty open. We're open to user feedback, developer feedback on how we can improve spend permissions and build other systems that complement it. Cool. Well, that's the brief overview of how the system works. Lukas is going to take over and give a sample workshop of our basic demo app. You can open this on your computer. It's github.com/Lukas Rosario /spend permissions demo. We'll leave this open for a moment for people to pull up. And also, before continuing, are there any questions about the overall idea or setup of spend permissions? Yeah.
What's the difference between batching transactions? What's the difference between batching transactions and having like a spend limit for, let's say, you have a $10 spend limit or $20 spend limit for the entire month? I'm trying to understand.
Oh, of that last point I had of batching permission approval?
Yeah, that one.
Yeah, so right now when you approve a spend permission, you're just signing a 712 object and nothing's actually happening on chain. And so an app could use that permission and immediately start applying it to pull money from you. So the batching permission approval idea is that you can use a transaction-based approval and then therefore batch other operations with it. So I could transfer ERC20s directly to the app and then also give it permission starting next month to withdraw my tokens. So it just makes the UX a little bit easier for the app.
Is it like, let's say, approve transaction as well as like swap transaction batched in a single transaction, and then you approve that?
Correct.
Is that? Oh, okay.
Yeah,
Got
yeah,
it.
yeah. And there are other ways we're also exploring batching where you could still do the 712 path and sign over multiple tokens at once. So a use case for this would be gaming. We've talked with Cattown, and they actually need ETH and Kibble, which is an ERC20, because they use the Kibble to fish, but they need the ETH for a Chainlink VRF fee. And so we'd still want to provide an easy way for users to sign once and approve multiple permissions at the same time. So that's the other pattern of batching. Yeah, another question.
Actually, like I already implemented the spend permissions in my app, like where I built an session keys based prediction markets, where users just swipe left and right for their action, and the app, it does the whole thing under the hood using the session keys and spend permissions. Like each transaction is 0.01 already capped. Like the user gives an allowance of 0.1 ETH every day, and we automatically abstract for 0.01 ETH. So the issue we occurred was like regarding the finality of the transaction. Like how does it occur? Like sometimes the transactions may fail, but we show the user like the transaction is succeeded because of the finality issues.
So if I understand the question, you have an app already on spend permissions.
Yes.
You have a daily refresh cycle, and then you're using the money to do some prediction market use case.
Yes, yes,
And some of the time, the transactions are failing.
yes. And
We should talk after then.
yeah, okay, thank you.
Yeah, I can help debug later.
Yeah.
Cool. Well, I want to hand it over to Lucas now. We'll take more questions throughout as well.
Cool. Yeah, so again, this code that I'm about to be showing is available at this repo. First, I'll just demo the app real quick. So yeah, this is a super simple app. This was spun up with on-chain kit, and I have a smart wallet connected here, and I can click the subscribe button. And what this does, this pulls up the 712 message to sign that Connor was talking about that describes the parameters of the spend permission. So you can see the limit per day is a lot. Starts on like forever ago. Not sure what that's about. And it's on base Apolia. So I can sign over this. And again, this is off-chain, so it doesn't cost any money or gas to approve a spend permission. So I can sign this. And then this signature is going to get shipped off to this app's backend, who can then use the signature along with the parameters of the spend permission to start pulling funds from my account. So that's what these are. These are all ops that are landing on chain. Yeah, so like every 5 seconds, the app will pull the backend to tell the app's like spending key to pull funds from the user's account. So that's like the short demo. And again, we're excited about this for like subscriptions, and this could show like this is kind of like a streaming payments kind of use case that I think could also be really cool. So we can go over the code actually real quick. So we can start with the front end piece here. There's nothing like super interesting here. Is this big enough? Maybe that's better. Yeah, so as mentioned, this is just like a regular 712 message. The parameters for these you can find on smartwallet.dev, and we have a guide up on spend permissions now, so you can see exactly how these are parameterized. So basically, when the user clicks this button, we define the spend permission. The account, this is the user's account. The spender, this is my, like if I'm an app, this is the account that can pull funds from a user's account. We have a spend permission for ETH for 10 a day, and this is these are the like recurring parameters, and then we have some extra fields here which you can find more about on smartwallet.dev. So we request a signature from the user, and then we make a request to the app's backend with that signature and the spend permission, and we can go see what that looks like. So the account that we're using to actually do the withdrawing from the user's account is a smart wallet, actually. So we wrap a private key in a smart account. And the reason we do that is because it's easier to do than like batching. We can do atomic batching, and we can also use paymasters. So when I was setting this demo up, I spent like 30 minutes trying to get basically an ETH, and I actually just ended up wrapping the account in a smart account and using a paymaster, so that's much easier. So you can see here, we have like a bundler client, and we send these calls to the permission manager. That's the contract Connor was mentioning. That's an owner of the user's smart accounts. So we have an approve a signature. So this actually approves the spend permission on chain, which needs to be done so that when the withdrawal calls get to the account, then the spend permission manager has like a record that the user actually did approve the spend permission. And then we have the spend call, which is saying, hey, I have the spend permission. Given that I want to withdraw 100 Wei from this account. And like I mentioned, we have this set up with a smart account and a paymaster so that I don't have to think about gas. This is just going to be sponsored by my paymaster. And then we return the hash to the client so that we can see that list of withdrawals in this case. And then we also have this other simple route that does collection when the spend permission is already pre-approved. So you can save some gas here by if the spend permission has already been approved on chain, you only need to call spend to withdraw tokens from the user's account. And again, using paymaster, and then we return the hash to the client, and that's where we get this this list of hashes, and then we just render those hashes and link them out to a block explorer. So yeah, again, this is available on this URL. Feel free to just pull it down and play around with it. And again, we have a guide available on smartwallet.dev, and that goes into all the parameters of the spend permissions and goes into more detail. And you can find out more about like use cases we're thinking about there. Any questions about the demo?
Hi, thanks. I'm wondering, is this the spending permissions is creating a session key, right?
No, because session key, we're trying to be very clear that spend permissions don't allow you to arbitrarily execute for the user's account. In other words, like the spender account is not an owner of the user's smart account. It just has the right to withdraw some assets from the user's account.
Okay, so it's an extremely scoped key that can only spend assets of the user's account.
Yeah, that's right, and that goes to like the. We just felt much better with the security model there, but you can pretty much get to session key parity and just build like, you know, if you wanted to have some state tied to the account, you can imagine in this backend having, you know, some database set up that's like, you know, I have this spend permission for this account. And I can just have my state there, and I don't need to execute directly from the user's account. And I just need the assets, which I can do.
And so, last question: the signature here is happening on the client side.
Yes, the user signs over the 712 message,
right.
Which basically like gives the ability for the app's spender to like pull funds.
Okay, so at each spend is using the signature that the user gave in order to use the permission.
You actually don't need the signature after you approve it on chain. So you just put a record into the manager contract that says, here's a signature for this spend permission. This is valid. And then next time when I want to pull funds, I don't need a signature again. I say, here's the spend permission. And there's a record of that on chain that it was approved.
Okay, thanks.
Yeah. Any other questions?
So this will only work with the Coinbase Smart Wallet?
Currently, yeah. Well, there's nothing stopping other wallets from implementing this this feature, but you would need to have the owner added as on your account. What else? There's a mic here too. Maybe not.
So the contract that we've written and audited only works for Coinbase Smart Wallet. However, we wrote it in a way that's easily forkable, where other people can just override a specific function of like what the execute looks like on their smart wallet. So for example, if you want to use, I guess, I think probably like a 0dev 7579 account has a specific execute function. You can just fork the spend permission manager, re-implement the execute function, whatever that interface looks like, and then everything else can just work the same pretty much. So one thing,
No.
yeah, one thing we are exploring is if spend permissions needs something like an ERC to make it easier for apps to work with other wallets on this kind of feature. We've held off from doing that to make sure that the design is actually sane first. But that is something that we're open to talking about and working on.
Okay.
Yeah, thank you. Cool.
Do you want to do your thing now?
Yeah.
If there are no other questions, Connor's going to show another demo of how you can tie this into like a social kind of app.
Actually, I think I may just like wing it on this one.
Okay. So do you want to plug in?
No, stay in for a second. Actually, I want to take it, chicken.
Yeah.
Cool, we are back. All right, so we're gonna do this like half live. We want to show a more concrete example of what it looks like to actually do advanced operation server side with spend permissions. And so what we're going to build is effectively something like this, where your smart wallet has some money, but we want to withdraw that money and spend to use some kind of operation. So Lukas was showing how earlier we could use a Coinbase Smart Wallet server side with a key that we can sign on demand. And with the Smart Wallet in the server, you gain two main things. You can use batch transactions, which we're going to show in this example, and you can also subsidize gas through paymasters to make it easy to not have to worry about topping up some random account you have with enough gas to submit transactions in an automated way. And so for this specific example, we're going to work with Zora's NFTs. That's just a good go-to protocol for anything NFT related and incentive alignment with your creators. And for us, the call flow is going to look something like this, where the entry point, because it's a 4337 account, is going to execute on our server account, which then has a server key we'll be signing with to verify. And then we're going to do two calls and batch them together. The first call is going to be spending on the smart wallet, which will prompt transferring some assets into it. And then the second call is going to be minting to the actual Zora NFT. We need to do the spend call before we do the mint call because we need ETH to perform the mint. The Zora's contracts will ensure that. It will only allow you to have the NFT if you're paying for it. And the mint two, emphasis on the two here, a lot of contracts out there allow you to define recipients for token-related operations. And so in our case, we're not going to be minting back to the server account here. We're going to be minting the token directly into the smart wallet itself. And by doing so, we create effectively what a session key experience is like with one-click mints, where the user only has to approve the permission to withdraw ETH. Then whenever they click the mint button, they're going to have the cloud account withdraw their ETH, mint something, and get it back in there atomically. This kind of model can also expand to other operations. So for example, DEX trading on swaps. The Uniswap router allows you to define a mint to like behavior as well, where you can define a number of recipients you want for your tokens. And so this is a case we're actually exploring with the team Dracula, where they support both swaps in their app and NFT mints. And we're working to move these operations to the server so that you can batch withdrawing money and buying something and giving it back to the user. And we think this model can actually be replicated across many other examples as well. And so what we want to do to start is I have an NFT collection on Zora. I've already done some sample mints in anticipation for the demo. But we have, this is just my PFP, and we have a contract address here. And so what we're doing, let's make that bigger. Cool. And so the first step here is rather simple. It's just the usual grant permissions experience. Again, you're just approving some ETH, and then you can do allow. And then from here, we have my PFP. This is the NFT I'm going to be minting. And then when we click mint, it should be making a query to the server to mint the token, which will then pull the assets if we have the route up here. 2 calls that we need. Or 3 calls rather. So again, we're approving the permission with the signature. We only need to do this once. After we have this approved on chain, we actually don't need to apply the signature anymore. But then we're pairing together both the spend of calling the spend permission manager to withdraw the amount we need for the mint. And then as soon as we have that mint value back in the spender client that we have, we can do a mint call. And then the mint call itself is going to make a call to the Zora minter contract with the mint cost and some data, which then just takes a bunch of stuff. But really what we need to define is the recipient, the NFT contract we're going to be minting on, and the token ID we want to mint. And after we have all of this, then we get a user op hash, user op receipt, and return this back to the client. So well, that's not supposed to happen. Apologies. Ooh. Let's do a live. Well, this was working just before I came back up, unfortunately, for us. But I have this pushed, a working version of it, to a repo that if you go to smartwallet.dev, we have all of this documentation here on spend permissions, including a basic overview, the quick start that has the sample experience Lukas just demoed as well. And then within here, if you go to the this one. Zora branch. You can access all of this code here within the app, and then we have a mint route that is doing this kind of API work. Wow. Cool. Wow. I'm curious, from the crowd, are there any applications that people are keen to build with something like spend permissions / session keys? Yeah.
So we are building like a generative art platform. So like the idea could be that like you as a collector, you can like approve spending, and each time like new mints come, it's automatically minted on your behalf. So you don't need to wait in front of the like minting button and refreshing the page. So that could be probably like idea I would have like with this.
That's cool. So this is something where as soon as a new token becomes available, like on the drop, I can mint?
Yes, exactly. So we have like weekly drops. So users don't need to wait like at, for example, 3 p.m. They don't need to wait. Like you see all the mouses going around because we have like a party kit. So you see all the like pointers. So they are impatiently clicking on the mint when it becomes like pink. So yeah, you approve, you're minting, and that's it. So at 3 p.m. sharp, you can mint for everyone who approached the limit.
Yeah, I
That
love
could
that.
be nice.
I like how in particular it helps people not be perennially online. And so this is a good
Yes.
use case of like the background transactions
Yes.
use case.
And we are already live on base, so happy to try it on.
I love it. Cool. Well, we skipped most of the workshop by having the code pre-pushed because we didn't want people to worry about typing live with us. So if people would like to build something together, we're here to finish the rest of the workshop. But otherwise, I think we have most of the content that we wanted to cover actually, and then leave the rest of it open-ended for what people wanted to build live.
So is the batch atomic or not? Or how does it work?
The batching on Smart Wallet is
Yes.
atomic. Yeah,
Okay.
it's only atomic.
Nice, thanks.
Was the account you were using to execute the Uniswap transaction in the example an EOA account, or is that another smart wallet?
In this one?
The Mint2 or the Uniswap, yeah.
Yeah.
The server account, what kind of account is that?
It could be any account that supports batching. So
Okay.
for us, we would just use the Smart Wallet because we know those contracts, but you can use anything as well up there.
Cool.
Yeah. It also doesn't have to be a 4337 account. It could just be a contract that supports batching. So like multi-calling, for example. Who is the one that calls execute on something like a server account? If it's a 4337 account, it would be the entry point because it's what's validating that you are actually you with your server key. And so after you validate your user op, then it'll submit a transaction or a call through the server account to then execute whatever batch you have. Yeah, another question.
So there's an entry point contract here, which is from 4337, right?
Yeah, correct. This entry point is the 4337 entry point.
Yeah, and so you guys created one more contract, which is the spend permission contract. This 7528. I'm a little confused. Can you explain what exactly is happening in the spend permission contract?
Yeah, what is happening in spend permissions? We can actually look at the code to show you some of the logic at play. It's relatively simple, but when you call spend on it, okay, this actually is going to be more complex than I was thinking. So when you do spend, it's going to do two things. It's going to validate all of the internal logic of, is this spending the right token? Is it spending too much of it for the current period? Part of the logic of spend permissions that's different from something like permit 2 or normal ERC20 approval is that there is a natural refresh of the permission over time. And so when you have a permission, I guess what Lukas showed you earlier was a TypeScript object. Here's the solidity struct we have. This period value is actually very important because it's what defines how long you go before you reset to 0. So for a subscription example, you would want the period to be your billing cycle. So 1 month, 1 year, bi-weekly, whatever it may be. For something like microtransactions, we've seen daily as like the most common way to do this. And so what the spend permission manager needs to enforce is that for the current period, have you spent more, have you spent up to the allowance? So if we go to use spend permission, that's what it's trying to do. So we just make sure that it's approved in some state that we have. If it's already approved in state, we look at what is the current period. Is the total spend for this period greater than what the allowance should be? And then if it is, it will fail. And otherwise, we can update our last tracked spend for the period. And so we would take the total spend and set it to the value, save it back in storage, and then emit an event that the spend permission has been used. And then after this, we would actually execute the ERC20 or ETH transfer.
So you mentioned in the beginning that we could fork this contract and then change something. What exactly was that? Oh, okay.
That would be this one, the execute. So the transfer from is just a normal transfer of either, if it's native token, it'll call on the account to transfer value to the recipient. If it's an ERC20, it'll call the token contract itself with the transfer function, defining the recipient and the value. It's really this execute internal that you can switch. So for us, we just import the Coinbase Smart Wallet interface, and we call its execute function. So whatever account you have, you can just replace this. Do you have more you want to go through? Yeah, let's try to fix the demo. Yeah. Actually, maybe we could help debug his thing as well. Red shirt. Yeah. 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 I want to take a moment to see if I can actually debug what was wrong with this minting, because it was working momentarily before. I thought I commented back in. Yeah, that's a good call. We all have the subscribe case. Actually, there is one more thing we should probably touch on as well that wasn't hit, which is people who want to build applications that have without a database. Hopefully that's like a lot of apps, at least many apps. They can use the blockchain as their database. One thing we've noticed is a need for providing index data about how many permissions have been used or how many permissions does your app already have. And so we've created a new RPC, wallet fetch permissions, that allows for that, where via API, you can always ping to know what permissions your spender actually has. And so you just provide the chain ID you're asking for. In this case, it only supports basic Polya, but soon everything else. Your spender address, that would be the server account in the examples we've been giving. And then what you get returned back is an array of these permissions. And for each permission, you would have all the fields and then the signature you need to apply. And for something like this, you would imagine a subscription would pull all of the accounts I have permissions for on a routine basis, and then for each of them prepare this massive batch call to call spend on all of the users. And so fetch permissions is something that we're also hesitant to go too deep into with something like an ERC, because we'd rather make sure the interface makes sense first through production experience. But patterns like this we also see as important for building full stack apps, kind of completing the CRUD, where you can create permissions. You also need an ability to read permissions. Soon we also need to add an ability for you to update a permission. For example, if you have a subscription that's $10 a month, but you want to upgrade someone to Pro, you need to say, would you like to upgrade? You were on 10, we're going to remove that, and only conditionally on removing it will we add a new permission for $50 a month. And then the final of delete, we already support revoking, but also being able to prompt to revoke from the app side as well.
Yeah, if there are no other questions, I think we can end early here. But Connor and I will be around if anyone wants to try out the repo or just has any questions about spend permissions in general. We're happy to hang around and chat. Thank you.